Hello everyone, so today we're going to solve quadratic equations by completing the square. So we're going to have 6 examples. Number 1, we're going to solve the quadratic equation x squared minus 2x minus 15 equals to 0 by completing the square. Number 2, we have x squared plus 4x minus 21 equals to 0. Number 3, we have x squared plus 1 equals to negative 4x. Number 4, we have x squared minus 5x minus 6 equals to 0. Number 5, we have x squared minus 10x equals to 50. And then last, number 6, we have 2x squared minus 8x plus 6. Let's start with our first example. Let's say we have x squared minus 2x minus 15 equals to 0. So, our first step in solving the quadratic equation by completing the square is by isolating the terms with x. So, here we have x squared minus 2x equals to, we add 15 on both sides of the equation, so we have positive 15. Then, after that, we're going to identify the term to be added to both sides of the equation to make a perfect square trinomial. So we have x squared minus 2x plus blank equals to 15 plus blank. Then next step is we're going to put aside. So we're going to get the middle term. The numerical coefficient of the middle term, we have negative 2. Divide it by 2 or multiply it by 1/2. So we have negative 2 divided by 2, we have negative 1. Then square it, that is 1. So we're going to add 1 on both sides of the equation. So we have plus 1, then plus 1. The next is we're going to factor the left side of the equation. So we all know the concept of perfect square trinomial. If you have x squared minus 2xy plus y squared, so that is equal to the square root of the first term, which is x, and then minus, since that this is minus, so minus y, then squared. So you're going to get the square root of the first term. Square root of x squared is x. Then, the square root of the third term, square root of y squared is y. Then, you're going to square it. Then, after that, if this is plus, of course, this is plus also. So, applying this concept, so we have square root of x squared x minus square root of 1 squared. Then, equals to 15 plus 1, we have 16. Then, next is we're going to use the square root property. Get the square root of both sides. So, we have x minus 1 equals to square root of 16 is positive or negative 4. Then, add 1 on both sides of the equation to get the value of x. So, we have x is equal to 1 plus or minus 4. The next, to get the first root or the first solution, we're going to get this 1 plus 4. So 1 plus 4, this is 5. Then the second root, we have 1 minus 4. This is negative 3. So we're going to check it to know if they are really the solutions of the equation. Okay. So, let us check. So, to check if x is equal to 5. So, using the original equation, so we have x squared minus 2x minus 15 equals to 0. So, you substitute, we have 5 squared minus 2 times 5 minus 15 equals to 0. Then 5 squared is 25. Then negative 2 times 5, we have negative 10. Then minus 15 equals to 0. Now, 25 minus 10, we have 15. Then minus 15 equals to 0. So 0 equals to 0. The next, if x is equal to negative 3, using again the original equation, we have x squared minus 2x minus 15 equals to 0. So again, by substituting the value of x in the original equation, so we have negative 3 squared minus 2 times negative 3 minus 15 equals to 0. The negative 3 squared, we have 9. The negative 2 times negative 3, we have positive 6. Then minus 15 equals to 0. 9 plus 6, we have 15. Then minus 15 equals to 0. So 15 minus 15, we have 0 equals to 0. So check. Now, as you can see, both values of x satisfy the given equation. Therefore, the solutions are 5 and or 3, negative 3. Okay. Number 2, let's say we have x squared plus 4x minus 21 equals to 0. So here, our first step is we have to make the left side free from the constant term. So we have x squared plus 4x. You add 21 on both sides of the equation, so equals to 21. The next is we're going to identify the term to be added to both sides of the equation to make a perfect square trinomial. So let us put aside. Let us get the numerical coefficient of the middle term. We have 4. You divide it by 2. We have 2. Then square it. We have 4. So we add 4 on both sides of the equation. So we have x squared plus 4x plus 4. Then equals to 21 plus 4. The next step is we have to factor the left side of the equation. So since that this is already a perfect square trinomial, we have to write that as a square of a binomial. So we have square root of x squared x, square root of 4, we have 2, then square it. Then equals to 21 plus 4, we have 25. Then after that, using the square root property, we have square root of x plus 2 squared. So the radicand itself, so we have x plus 2. Then equals to square root of 25, we have positive or negative 5. Then x is equal now to negative 2 because we subtract negative 2 on both sides of the equation. So negative 2 plus or minus 5. Then let us solve the value of or the solutions. Let us solve for the solutions. For the x of 1, we have negative 2 plus 5. So we have positive 3. For x of 2, we have negative 2 minus 5. So we have negative 7. Let us check. So we have 3 and the negative 7 as our solutions. So let us check. 3 and negative 7. So to check if x is equal to 3, Then, again, using the original equation, so we have x squared plus 4x minus 21 equals to 0. So you substitute the value of x, which is 3, to the equation. We have 3 squared plus 4 times 3 minus 21 equals to 0. 3 squared is 9 because 3 times 3 is 9. Plus 4 times 3 we have 12. Then minus 21 equals to 0. 9 plus 12 we have 21. Minus 21 equals to 0. So 21 minus 21, 0 equals to 0. Check. If x is equal to negative 7, then we have x squared plus 4x minus 21 equals to 0. Again, you substitute the value of x, which is negative 7. So we have negative 7 squared plus 4 times negative 7 minus 21 equals to 0. Then we have negative 7 squared, we have 49. Then 4 times negative 7, we have negative 28. Then minus 21 equals to 0. So 49 minus 28 is 21. Minus 21 equals to 0. 21 minus 21, 0 equals to 0. Check. So since that both values of x satisfy the given equations, therefore the solution, okay, therefore the solutions of the equation, the solutions of x squared plus 4x minus 21 equals to 0 are 3 and negative 7. Number 3, we have x squared plus 1 equals to negative 4x. So isolating the terms with x variable, so we have x squared, then you transpose negative 4x to the left side, from positive make it, from negative make it positive 4x. Then equals to, you transpose again 1 to the right side of the equation, from positive 1 make it negative 1. Or you just make use of the addition and subtraction property of equality. The next step is we have to identify the term to be added to both sides of the equation to make a perfect square trinomial. So we have to put aside, so get the numerical coefficient of the middle term 4, then divide it by 2, so we have 2. Then square it, we have 4. Then add 4 on both sides of the equation, so we have x squared plus 4x plus 4, then equals to negative 1 plus 4. The next is you have to rewrite this as a square of a binomial, since that this is already a perfect square trinomial. So you get the square root of the first term. Square root of x squared is x. Square root of 4, we have 2. Then square it. So equals to 1, negative 1 plus 4, we have 3. Then using the square root property, we have square root of x plus 2 squared is x plus 2. Then square root of 3 is, so 3 is not a perfect square, so we have positive or negative square root of 3. So we will just copy that radical. Then using the subtraction property of equality, so we have x is equal to negative 2 plus or minus square root of 3. Then our first solution is negative 2 plus square root of 3. Second solution is negative 2 minus square root of 3. Okay. Next, let us check. So to check if x is equal to negative 2. Let's see. Negative 2 plus square root of 3. So using the original equation, we have x squared plus 1 equals to negative 4x. So, the value of x here is negative 2 plus square root of 3. You substitute, we have negative 2 plus square root of 3 squared plus 1 equals to negative 4 times negative 2 plus square root of 3. Okay. Next is, we're going to use the concept of finding the product of y square of a binomial, that if we have x plus y squared, so its product is the square of the first term plus twice the product of the first and then the second term, then plus square of the second term. So, the first term here is negative 2. The second term is square root of 3. Then, applying the concept, we have negative 2 squared plus, because here we have addition. So, plus twice the product of the first term, which is negative 2, times the second term, 3. Then, plus square of the second term. So, square root of 3 squared. Then, plus 1. Then, equals to this one. Negative 4 times negative 2. So, we have positive 8. Then, negative 4 times square root of 3. So, here, the numerical coefficient of square root of 3 is 1. So, negative 4 times square root of 3 is negative 4 square root of 3. Then, after that, let us simplify. We have negative 2 squared, or negative 2 times negative 2, we have positive 4. Then, next, 2 times negative 2. So, we have negative 4. Then, you will just copy square root of 3. Because positive 2 times negative 2 times square root of 3 is negative 4 square root of 3. Then, plus square root of 3 squared. Now, this is 3. Okay. Then, plus 1 equals to 8 minus 4 square root of 3. Are they equal? Let's see. So, we have 4 plus 3 plus 1. So, we have 8, right? So, we have 8 minus 4 square root of 3. So, you will just combine similar terms here. So, 4 plus 3 plus 1, we have 8. Then, you will just copy the radical. So, we have negative 4 or minus 4 square root of 3. Then, equals to 8 minus 4 square root of 3. So, check. They are equal, right? Next, how about if, let's see. So, let us remove this. Okay, if x is equal to negative 2 minus square root of 3. Using the original equation, we have x squared plus 1 equals to negative 4x. So, we have, okay, again, substitute, we have negative 2 minus square root of 3 squared plus 1 equals to negative 4 times negative 2 minus square root of 3. Again, using the concept of squaring a binomial. So, we have 2 square the first term, negative 2 squared. Then, since that here, the operation is minus here. So we have to minus. So we have to subtract. So minus 2 times the first term, which is negative 2, times the second term, which is square root of 3. Then plus square of the second term. So square root of 3 squared. Then plus 1 here. Plus 1. Then equals to, next, negative 4 times negative 2. That is positive 8. Then negative 4 times negative square root of 3. So we have negative times negative, positive 4 square root of 3. The next, let us simplify negative 2 squared, or negative 2 times negative 2. We have positive 4. Then negative 2 times negative 2, we have positive 4 times square root of 3. We have 4 square root of 3. Then plus square root of 3 squared, we have 3. Then plus 1 equals to 8 plus 4 square root of 3. So let's see. Let us combine similar terms. We have 4, 3, and 1. So 4 plus 3, we have 7. Plus 1, we have 8. Then plus, you just copy 4 square root of 3. So plus 4 square root of 3. So equals to 8 plus 4 square root of 3. Check. Now, as you can see, that both values of x satisfy the given equation. Therefore, the solutions are the solutions of x squared plus 1 equals to negative 4x are negative 2 plus or minus square root of 3. Okay, number 4, let's say we have x squared minus 5x minus 6 equals to 0. So first step is we're going to isolate the terms with x variable. So we have x squared minus 5x. Then equals to 6. So you're going to add 6 on both sides of the equation. Then next is we're going to identify the term to be added to both sides to make a perfect square trinomial. So what are we going to do is we have to put aside. So here, as you can see, the numerical coefficient of the linear term is negative 5. You're going to divide it by 2 or multiply it by 1/2. So as you can see, we have fraction. Then square it. So we have positive 25 because negative 5 squared is 25. Negative 5 times negative 5, positive 25. Then 2 squared, or 2 times 2. So we have 4. Then we're going to add 25 over 4 on both sides of the equation. So we have x squared minus 5x plus 25 over 4. Then equals to 6 plus 25 over 4. The next step is, as you can see, since that the left side of the equation is already in a perfect square trinomial. So what are you going to do is you have to factor that. Now, we're going to write that as a square of a binomial. So we have square root of x squared. So we have x minus square root of 25, we have 5. Then square root of 4, we have 2. Then square it. Equals to 6 plus 25 over 4. So we all know that the denominator of this is 1. Then we're going to get the LCD. LCD is 4. So LCD means the least common denominator. Then 4 divided by 1, we have 4. Times 6, we have 24. Plus 4 divided by 4, we have 1 times 25, we have 25. Then next, we have x minus 5 over 2 squared equals to 24 plus 25 is 49 over 4. The next is applying the square root property. So we have, let's remove this. Okay, so we have square root of x minus 5 over 2 squared is x minus 5 over 2. Then equals 2. Square root of 49 over 4. So we have positive or negative. 7 because square root of 49 is 7. Then square root of 4 is 2. Then the value of x here is, again, using the addition property of equality, we're going to add 5 over 2 to both sides of the equation. So we have positive 5 over 2 plus or minus 7 over 2. So let us solve for the solutions. X of 1. So we have positive 5 over 2 plus 7 over 2. Then 5 plus 7, we have 12. Divided by 2, we have 6. So this is the first solution. The next solution, x of 2, we have 5 over 2 minus 7 over 2. So 5 minus 7, that is negative 2, divided by 2. So here, since that they are similar fractions, then what are you going to do is you will just copy the same denominator, which is 2. The negative 2 divided by 2, we have negative 1. Okay, so this is not yet the final answer because we're going to check. Okay, so to check, we have if x is equal to positive 6, so using the equation, so we have x squared minus 5x minus 6 equals to 0. So substitute, the value of x is 6. So 6 squared minus 5 times 6 minus 6 equals to 0. 6 squared is 36. Then 5 times 6, we have 30. So negative 5 times 6, we have negative 30. Then minus 6 equals to 0. 36 minus 30, we have 6 minus 6. So equals to 0. Of course, 6 minus 6, 0 equals to 0. Check. How about if x is equal to negative 1? So same, using the same equation, using the original equation, we have x squared minus 5x minus 6 equals to 0. Then, you substitute, we have negative 1 squared minus 5 times negative 1 minus 6 equals to 0. Negative 1 squared or negative 1 times negative 1, we have positive 1. The negative 5 times negative 1, we have positive 5. Then minus 6 equals to 0. 1 plus 5, we have 6 minus 6 equals to 0. So 6 minus 6, 0 equals to 0. So check. Now, as you can see, both values of x satisfy the given equation. Therefore, we can say that the solutions of the equation, that's that, x squared minus 5x minus 6 equals to 0, are 6 and negative 1. Sometimes you can write x is equal to 6 and x is equal to negative 1. So, that's the solution for number 4. Okay. So if you have questions, you can comment below and then I'll answer it for you. Number 5. Let's say we have x squared minus 10x equals to 50. Now, as you can see, no need for us to isolate the x variable. So, what are we going to do is, we're going to put aside. So, the numerical coefficient of the linear term is negative 10. You divide it by 2 or multiply it by 1/2. So, we have negative 5. Then, square it. So, that is 25. Because negative 5 times negative 5, you have positive 25. So, we're going to add positive 25 on both sides of the equation. So, we have x squared minus 10x plus 25 equals to 50 plus 25. The next is, this is a perfect square trinomial already. So, we're going to write that as a square of a binomial. So, square root of x squared x minus square root of 25, 5. Then, squared equals to 50 plus 25. This is 75. Okay. The next is we have to apply the square root property. So, getting the square root of both sides, we have square root of x minus 5 squared. So, we have x minus 5. Then, equals to square root of 75. So, we have positive or negative square root of 75 is not a perfect square. But then, you have to think of the factors of 75 wherein one of its factors is a perfect square. So we have, that's 25 and 3, right? So 25 times 3, we have 75. So we have x minus 5 is equal to positive or negative. Square root of 25 is 5. Then, since the 3 is not a perfect square, so you will just copy 3. Then after that, to get, let's erase this one. Okay. Then, to solve for x, you're going to add 5 on both sides of the equation. So, we have x is equal to 5 plus or minus 5 square root of 3. If you don't want to make use of addition property of equality, you can transpose negative 5 to the right side. But then, see to it that you will change the sign from negative, change it to positive. Okay, so this is the value of x. But then, we're going to solve for the solution. So, x of 1 is equal to 5 plus, you will get the first operation. We have 5 plus 5 is square root of 3. Then, so that's it. That's x of 1. Then, x of 2 is 5 minus 5 is square root of 3. Now, you can combine these two terms. 5 and then 5 is square root of 3 because they are not similar terms, right? This is a whole number, this is a radical. So, you cannot combine the two terms. So, let us now check. To check if x is equal to positive 5 plus 5 is square root of 3. Using the original equation, we have x squared minus 10x equals to 50. So, let's see. So, the value of x here is 5 plus 5 is square root of 3. Okay, squared minus 10 times 5 plus 5 is square root of 3 equals to 50. Now, again, As you can see, this is a square of a binomial. To find the product, again, we're going to make use of the concept of finding the product of a square of a binomial. So we have x plus y squared. So the product of that is that the square of the first term plus twice the product of the first and then the second term plus square of the second term. If this is minus, so of course here, this is minus also. Okay. So, first term is 5, right? And then the second term is 5 square root of 3. So, let us square the first term. So, 5 squared plus twice the product of the first term, which is 5. And then the second term, 5 square root of 3. Then plus square of the second term. We have 5 square root of 3 squared. Then minus. So here, negative 10 times 5. So we have negative 50. Right? Then negative 10 times 5 square root of 3. So here, you will just multiply negative 10 and then 5 because 5 is the numerical coefficient of this radical. So we have negative 10 times 5, we have negative 50. Then you will just copy square root of 3. So let us make it readable. Okay. So we have 50 square root of 3. Okay, next. Then equals to 50. Okay, so we have 5 squared is 25. Then plus 2 times 5, we have 10 times 5, the numerical coefficient, we have 50. Then square root of 3. Then plus 5 squared. So you're going to square first this one, the numerical coefficient 5. So that is 25. 5 squared is 25. Then square root of 3 squared. So we have 3. So you're going to multiply it by 3. For those who ask, why is it that square root of 3 squared is equal to 3? So, I think you know now the answer that if you're going to write that into exponential form, so this is equal to 3 raised to the exponent 2 over the index here 2, right? So, we have 3. Because 2 divided by 2, we have 1. So, the answer is 3 only. So, times 3. Then minus 50. Then minus 50 square root of 3. Then equals to 50. Are they equal? Let's see. So, combine. Let us simplify first this one. So, we have 25 okay, so we have 25 plus 50 square root of 3 plus 25 times 3, we have 75 minus 50 square root of 3, then equals to 50. Then let us now combine similar terms. Similar terms here are 50 square root of 3 and then negative 50 square root of 3. So we can cancel 50 square root of 3 and then negative 50 square root of 3. The next, we have 25 plus 75. So that is 100. Now, minus 50, we have 50. 100 minus 50, we have 50. Okay. So, see, they are equal. Next, how about if x is, okay, so let us put it here. If x is equal to 5, let's see, 5 minus 5 square root of 3. Okay. Okay, using the original equation, again, we have x squared minus 10x then equals to 50. So here, the value of x is 5 minus 5 is square root of 3, square root of 3. So we have 5 minus 5 is square root of 3 squared minus 10 times 5 minus 5 is square root of 3 then equals to 50. The next, again applying the concept of finding the product of the square of a binomial, that if we have x plus or minus y squared, so that is equal to the first square of the first term, then twice the square of twice the product of the first term and then the second term, and then plus square of the second term. So the first term here is 5. Okay, so notice that the first term is 5. The second term is 5 square root of 3, right? Again, same procedure. So we have to square the first term minus, because the operation is minus, then, or subtraction, then 5 squared minus twice the product of the first term, 5, times the second term, 5 square root of 3, right? Then plus square of the second term, 5 square root of 3. Okay. Then, this one. Again, negative 10 times 5, we have negative 50. Then, negative 10 times negative 5, we have positive 50. Then, you will just copy square root of 3. Then, equals to 50. Next, simplify. We have 5 squared, we have 25. Then, 2, negative 2 times 5 times 5. So, 10 times 5, we have 50. Negative 50 square root of 3. Then, plus. So, 5 squared. That is 25. Then, square root of 3 squared, we have 3 only. Then, minus 50 plus 50 square root of 3, then equals to 50. Then, let us now copy 25 minus 50 square root of 3 plus 25 times 3, we have 75, minus 50 plus 50 square root of 3, then equals to 50. Then, let us now cancel. Let us combine similar terms. So, the similar terms here are the whole numbers, right? We have 25, 75, 50, negative 50. Then, we also have negative 50 square root of 3 and then 50 square root of 3. They are similar terms. So, since that one is negative and then the other one is positive, so we can now cancel that. Okay. Then we have 25 plus 75 is 100. Minus 50. So we have 50. So 25 plus 75, we have 100. Minus 50 equals to 50. So we have 50 equals to 50. Check. Okay. So, as you can see, both values of x satisfy the given equation. Therefore, okay, the solutions therefore, the solutions of the equation x squared minus 10x equals to 50 are 5 plus or minus 5 square root of 3. You can write also x is equal to 5 plus or minus 5 is square root of 3. Number 6, let's say we have 2x squared minus 8x plus 6 equals to 0. So, as you can see, a here is not equal to 1. So, it's okay. So, let us isolate first the constant term. So, we have 2x squared minus 8x equals to negative 6. So, the constant term here is negative 6, right? So, you will just subtract 6 on both sides of the equation. The next, to remove or to make the numerical coefficient of the quadratic term 1, so what are we going to do is you have to divide each term by 2. Okay? So, you cancel this. We have x squared. Then 8x divided by 2, we have negative 4x. Then equals to negative 6 divided by 2, we have negative 3. Then after that, we're going to put aside. So, making the left side perfect square trinomial, we have to get the numerical coefficient of the linear term, which is negative 4. You divide it by 2, so we have negative 2. Then after that, you square it, so we have 4. Now, add 4 on both sides of the equation. So, we have x squared minus 4x plus 4. Then equals to negative 3 plus 4. Next, as you can see, the left side of the equation is already a perfect square trinomial, right? So, what are you going to do is you have to rewrite that as a square of a binomial. So, square root of x squared is x. Then, minus square root of 4, we have 2. Then, square it. Then, equals to negative 3 plus 4, we have 1. The next, using the square root property, so let us get the square root of both sides. So, let us make it clean again. Okay. Okay. Then, we have the square root of x minus 2 squared. We have x minus 2. Then, equals to square root of 1 is, okay, 1. So, we have positive or negative 1. Then, add 1 on both sides of the equation. So, we have x is equal to positive or negative 1 plus 2. Or 2 plus or minus 1. Then, x of 1 is 2 plus 1 equals to 3. X of 2 is 2 minus 1 equals to 1. Okay? So, again, we're going to check. If x is equal to 3, using the original equation, we have 2x squared minus 8x plus 6 equals to 0. So, you substitute. We have 2 times 3 squared minus 8 times 3 plus 6 equals to 0. Then you copy 2 times 3 squared is 9. Then minus 8 times 3, we have 24. Plus 6 equals to 0. Now, 2 times 9, so we have 18. Minus 24 plus 6 equals to 0. 18 minus 24 is negative 6. Then, plus 6 equals to 0. Negative 6 plus 6, we have 0 equals to 0. Next, if x is equal to, let's see, the value of x is 1. Okay. So, if x is equal to 1, so using again the original equation, x squared minus 8x plus 6 equals to 0. So, we have 2 times 1 squared minus 8 times 1 plus 6 equals to 0. Then we have 1 squared is 1. Times 2, we have 2. Minus 8 times 1, we have 8 plus 6 equals to 0. So, 2 minus 8, we have negative 6 plus 6, we have 0. Then, negative 6 plus 6, we have 0 equals to 0. Check. So, both values of x satisfy the given equation. Therefore, we can say here that the solutions of the equation 2x squared minus 8x plus 6 equals to 0 are 3 and 1. Okay. So, thank you. That's all. If you have questions, just comment below and then I'll answer it for you. Thank you for watching this video. I hope you learned a lot today. Just like, comment, subscribe, and click the notification button for more videos. Thank you.